Hi everyone, this is lecture 2.3 and today we're going to be talking about the product rule. We're going to go straight into example 1 from the learning resources. Let f of x equals to h of x times g of x, where h of x equals to x squared plus 2 and g of x equals to x plus 5. Show that the derivative of f of x does not equal to the derivative of h of x times the derivative of g of x. Let's start once again by writing down our original equation. We know that f of x equals to h of x. H of x equals to x squared plus 2, and g of x equals to x plus 5. So we plug these two expressions back into this equation. If we simplify that, that will be x cubed plus 5 times x squared plus 2x plus 10. And the derivative of this will be 3x squared plus 10x plus 2. The derivative of h of x is 2x and the derivative of g of x is 1. So if we have h prime x times g prime x, that's going to give us 2x. Obviously 2x does not equal to this expression, therefore we say that the derivative of f of x does not equal to the derivative of h of x times the derivative of g of x. So if this expression is not true, then what is the proper expression for the product rule? If h of x equals to f of x times g of x, then the derivative of h of x will be equal to f prime x times gx plus f of x times g prime x. Let's try to prove this. Supposedly we have p of x equals to f of x times g of x. We write our limit equation down for the derivative of p of x. That's going to be p of x equals to limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. To evaluate this limit, we have to subtract and add the same term in the numerator to make sure the value of the overall expression does not change. Let's add f of x times g of x plus h and minus the same term. Because now what we can do is we can take out g of f plus h from both of these terms out. And then we can take f of x from these two terms out. What we're left with is limit as h approaches 0 of f of x plus h minus f of x over h times g of f plus h plus f of x times g of x plus h minus g of x over h. We see that the limit of this equals to f prime x and the limit of this equals to g prime x. Therefore, the derivative of px will be equal to f prime x times gx plus fx times g prime x. Now let's take a look at example 2 from the learning resources. Differentiate the following function. H of x equals to x squared minus 3x times x to the power of 5 plus 2 using the product rule that we just learned from the previous slide. Once again, we're asked to differentiate h of x, and from the previous slide we know that h of x equals to f of x times g prime x plus g of x times f prime x. In this case, f of x will be equal to this first expression and g of x will be equal to this second expression. When we plug in the value and simplify it out, that will be equal to 7 times x to the power of 6 minus 18 times x to the power of 5 plus 4x minus 6. Now let's take a look at the power of a function for positive integers. If u is a function of x and n is a positive integer, then the derivative of u to the power of n will be equal to n times u to the power of n minus 1 times the derivative of u. There is an example of this in your learning resources. Unfortunately, we're not going to cover that in lecture today, so feel free to check that out. And that's the end of your lecture. Thank you guys for watching. Remember to do your assignment as well as upload them for your teacher to mark. And